Hello and welcome you all. Today in this video, we will study some important aspects of functions. Here we will also study domain, range and codomain of a function. Student, in the last video, we have studied that a relation f from A to B is said to be a function if every element of set A has one and only one image in set B. That is, all elements of set A are associated to elements in set B, or all elements of set A is associated to a unique element in set B. So from here, student, a function is a rule that gives new elements out of given elements. So to understand it, let us consider a function fx equal to 3x. Here, x belongs to natural number and fx is also belongs to natural number. And now when we put the value of x, which is equal to 1. So from here we get f of 1 is equal to 3 into 1, which is equal to 3. And now when we put x is equal to 2, we get f of 2 is equal to 3 into 2, which is equal to 6. And now when we put x is equal to 3, so from here f of 3 is equal to 3 into 3, which is 9. And now when we define our relation in roster form, which is equal to 1, 3, 2, 6, 3, 9 in closed curly braces. So in these ordered pair of our relation are here, let's say in 1, 3, here 1 belongs to x and fx belongs to 3. And now we will define this relation into set builder form. So let's say our relation R from n tends to n. Therefore, R is equal to x, fx in closed curly braces such that fx is equal to 3x. For every x belongs to n and fx is also belongs to n. And now we will understand it with the help of arrow diagram. As per our function fx equal to 3x, where x belongs to natural number and fx is also belongs to natural number. So let's say set A, where I have written all the sets of natural number, say 1, 2, 3, 4, 5 and so on. And in set B, the values of fx. So from here, 1 is related to 3, 2 is related to 6, 3 is related to 9. So here in this arrow diagram, we have observed that every natural number in domain have some images in codomain. Means all the elements of domain must have a unique image in codomain. And now let us consider a function fx, which is equal to x square minus 1 upon 4x. Here our function f is from R tends to R. At x is equal to 1, we get f of 1 is equal to 1 square minus 1. So 0 upon something is 0. And at x is equal to 0, we get f of 0, which is equal to minus 1 upon 0. And this is equal to not defined. So this function is not defined at x is equal to 0. Therefore, f from R tends to R is not a function, because this element 0 in domain does not have its image in codomain. So therefore it is not a function. So to make it a function, let's say if fx is equal to x square minus 1 upon 4x. Here, as we know that at x is equal to 0, this function is not defined. So here we can write this as f such that all the real number except 0 tends to R. Now here we have eliminate 0 in our domain. So now student, this fx is our function. And now we will study domain, range and codomain of a function. So as we have already studied in relation that domain is the first element of all the ordered pair and range is the all the second component of the ordered pair. So in function, domain is the set of values of x at which function is defined. Say in the above example where fx equal to 3x, here 1, 2, 3, 4, 5 up to natural number, these are our domain and the values, like at f of 1 is equal to 3, f of 2 is equal to 6 and f of 3 is equal to 9. So this 3, 6 and 9 is our range. And now in this above arrow diagram, here if someone asks you that what is the image of 1, then your answer is 3. And then image of 2, then your answer is 6. And if someone asks you to find the pre-image of 3, so the pre-image of 3 is 1 and pre-image of 6 is 2 and similarly pre-image of 9 is 3. So from here we can say that if our function f from A to B such that f of A is equal to B, here B is called image of A under F and A is called pre-image of B under F. And now student, let us consider one more function, which is fx is equal to x square. Here f is from A to B such that set A is equal to minus 2, minus 1, 0, 1, 2 in closed curly braces and B is equal to 0, 1, 2, 3, 4, 5, 6. And as I have already told you that this function f from a to b, here a is the elements of domain and b is the elements of codomain. So when we put the values of set a in our function fx, we get f of minus 2 is equal to minus 2 whole square, which is equal to 4, and f of minus 1, which is equal to minus 1 whole square, and this is equal to 1, and f of 0, which is equal to 0, and f of 1 is equal to 1, and f of 2 is equal to 4. So clearly each element of set a is associated to a unique element of set b. So in this, the domain of our function fx equal to minus 2 comma minus 1 comma 0 comma 1 comma 2 in close curly braces, and range of this function is equal to 0 1 4 in close curly braces, and codomain is all the elements of set b. So this is the end of this video. Thank you so much and have a great day ahead.